Hello, hello, hello. Good afternoon, everyone. Um, Thank you for being here at this presentation. My name is Álvaro Sánchez, and I'm going to talk to you about Java Annotation Processing. Let me introduce myself. I'm coming from Madrid, from Spain. I'm a Java developer. Always been a Java developer, just on JavaScript, but I regret doing that. I've been working on Micronaut since the beginning, so since 2017, that's when we started. And I'm working at Oracle, more concretely at Oracle Labs, where we are a sibling team of the GraalVM team that you may know of, working on a few things. I'm not a developer advocate myself, just a regular committer on the project. But I enjoy going to conferences like this one to talk about Micronaut, GraalVM, and whatnot. On a personal note, I'm a runner. Yes, I know you're surprised now. I run a lot. I run containers, applications, and I run them very fast, very fast. Also, let me tell you another thing. I'm telling you that I started working on Micronaut since the beginning. Originally, this wasn't called Micronaut. It was called Particle. That was the code name when we started. But Particle, we couldn't choose that name because the domain name was not available. There was a trademark from a different project. So we had to choose a new name. And we ran a poll internally across the team to choose a new name. And I proposed an option which wasn't selected. I still don't get why, because I think it's great. You will tell me. So my proposal was to name the framework Summer, because we all know that summer is better than spring. It's a bad joke. I'm literally a former VMware employee. It's a great company, great framework. But let's talk about not even Micronaut, but annotation processing. So slides are available on speaker deck. And in the meantime, let me run a quick poll across all of you. So who's using Spring Boot? Yeah, you can all leave the room. Thank you very much. No, that's OK. We still love you. Who's using Quarkus? OK. Who's using Micronaut? You're a good one. All right. Who knows what happens, especially those of you using Spring, who know what happens when you use an annotation like, for example, a transactional in Spring? Who know what happens under the covers? Magic, yeah, but who know what's the magic trick behind it? Or the magic tricks behind them? No one raising the hand, which means that you're in the right place to learn about that. So normally, annotation processing in Java is two stages process. First of all, you need to discover the annotated element. So when we use a transactional, we put the annotation typically on a method. There are others, like, for example, REST controller, you put that on a type. And once you've found the annotation, you have to implement the logic, to do something with it. And there are different techniques and approaches that I will go through. I will start with runtime annotation processing, which is what Spring is using, essentially. So basically, when you have a Spring application, Spring will traverse your class path, all your class path, right? It will look for annotations. Well, not all your class path, but basically, will restrict to a given package. And we'll use the Java Reflection API to basically query which annotations are on a type, on a method, or on a field, right? So it will use reflection on classes, methods, and fields to basically detect the annotations, right? Remember, we're still in the first stage. We're still discovering the annotations, right? Now, this being said, it's true that there is a new Spring module called Spring AOT, where it's basically an attempt to reduce these runtime operations and to produce some of this metadata during compilation, right? But like classic Spring Boot, this is how it works. There's more alternatives out there in the Java ecosystem. Like, for example, you can use a library called ClassGraph. This is only interesting if you're going to implement a framework or a library. ClassGraph is using a different approach because the class path scanning mechanism has a problem, and is that because this is happening when your application is starting up, you need to load the class into the class loader. So you're loading the classes, all of them, right? And then once the class is known to the class loader, you can use the reflection API to say, OK, give me the annotations of the type, or give me all the methods, and then you get a method handle. And with the method handle, you query which annotations are in the methods, etc. Now, this library has a different approach, and is literally parsing the bytecode directly. So this is avoiding loading the classes, right? So it has its own byte parser, and it can read classes within a jar file. And it's really highly optimized. But this is a library that is not is unfortunately not used by Spring or any major framework, so you could use it yourself if you wanted to. There are many other alternatives, like, for example, Burning Wave Core is another alternative. But yeah, let's talk about more things. So those are basically the options that you have to discover the annotation. So you either use class path scanning plus reflection, or use a third-party library, which will do differently. Now, how do we implement the annotation? Like, for example, transactional. Transactional is not a very complex example, because essentially all you had to do is to intercept the method call and to put the transaction logic around your method invocation, right? The basic approach are dynamic proxies. Dynamic proxies is a Java built-in capability. This comes out of the box. Requires no libraries, right? It's built into the JDK. And there is an API coming from the proxy class that will allow you to generate on the fly an implementation for interface. Right? So we're generating bytecode at runtime. Through the presentation, I'm including these little warning icons to highlight things that are not so great. Like generating bytecode at runtime while your application is starting up is going to cost resources and startup time, basically. Another limitation of this approach is that it can only generate implementation for interfaces. So if you use, for example, if you use a repository on an interface, that's going to be fine, but transactional on a normal class is not going to work. So in this case, for example, Spring is using a third-party library called cglib. cglib is quite mature library. It's been there like forever. And it's used by Spring and many other libraries to basically generate dynamic proxies for anything, not just interfaces. Can also be used for, they call it dynamically enhanced, but I read this as mutate existing classes, which I think is problematic. We'll discuss about this later. cglib itself is no longer maintained because it's difficult for them to keep up with all the JDK changes. But fortunately for you, Spring has their own fork, which they maintain, so you don't have to worry about. And many of these alternatives use a low-level library called ASM. ASM is like the foundation library that almost everyone is using under the covers to produce bytecode manipulation. What else do we have? We have, for example, ByteBuddy. Who's heard about ByteBuddy before? Yeah, so ByteBuddy is a popular library. It's quite modern, and it's used by, for example, Hibernate, Mogito Jackson, Selenium, Spock. Like many libraries are using ByteBuddy. ByteBuddy, same as CGlib, allows generating or changing classes. You can do it. You can do it like with a Java API. You can use a Java agent, or you can do it during build time, right? It is fast, considering that this is happening at runtime, right? It has a modern API, it's very well maintained, documented. There are lots of examples. So if you ever need to do bytecode generation at runtime, I would go with this library. And finally, the other option that I will mention, there is a Java enhancement proposal for standardizing all of this, and it's called the Class File API. It is currently in preview. It's being targeted for the next Java release, so in a couple of months. And it's essentially an internal replacement for ASM, because guess what? The JDK itself is using ASM. It's using a fork of ASM. That way they keep it internally, right? And it's very difficult to work with ASM inside the OpenJDK itself, because you can't make an ASM version compatible for an unreleased OpenJDK version. So they have this chicken and egg problem. And also ASM, they call it like a very old code base. So it's a replacement of that, right? So let's see an example. Imagine we wanted to have a simple annotation called timed, which I have over here somewhere. Is this big enough? Yes. This is a simple annotation. Now I'm going to be processing this annotation at runtime, so I need the retention to be runtime, which means that in the bytecode, this annotation will show up for all the annotated classes. And now I have a simple service, not this one here, sorry, but in this case, I have this one here. Is a service that is using the @timed annotation on a method, and this will basically calculate how much time this method invocation has taken. So this is very simple, because the implementation has essentially to intercept a method call to this. If this had been an interface, I could have generated a proxy. But with ByteBuddy, I'm generating a new class. And it has to intercept a method call to the do something method, and then essentially calculate the time. Now, the way to do that with ByteBuddy is very simple, because there is a simple API. So you basically say, I want to subclass my time service. I want the class to be named like the name of the class plus this suffix. And then I want to intercept methods annotated with timed, and delegate the implementation to this interceptor here. And this is basically where the logic of the interceptor is being kept, right? So we calculate the time at the start, the time at the end, and print the result. Very simple, right? If we run this, it simply works. This implementation is so the service itself is doing random weight, so that we get different numbers each time, right? So now is need a tooltip to disappear. Come on, tooltip, please go away. So it's a couple of seconds. If I run this in debug mode, because I'm generating a subclass, and then I'm using reflection to instantiate this class. You still follow me? Blink your eyes if you still follow me. Thank you. So I have a reference of type my time service, but this is not my time service. This is my proxy. Okay? This happens in Spring everywhere, in Hibernate everywhere. And as a consequence, the stack traces are going to be gigantic because you're no longer working with your classes and objects anymore, but this is proxies happening at runtime. So far, so good? So what's wrong with this? First of all, class path scanning is slow. So be sure that you restrict it to the smallest possible package. It normally happens on the application package, the main application, and then you have sub packages there. But essentially, class path scanning is really slow. The reflection API is slow. And it's true that in every new Java release, it's a bit faster than in the previous one, but it's still a slow API. And because of that, what happens is that frameworks and libraries will cache the information. So you're not going to query over and over again which are the annotations on my time service or which are the annotations on the do something method, right? I'm not interested in using the reflection API every time. So they cache that on memory. So memory consumption will increase. But guess what? You're probably not only using Spring, but also Hibernate. So who's using Hibernate here? So Hibernate is also heavily based on reflection. And the Hibernate reflective cache is different than the one from Spring. So you have more memory consumption. There's no limit, by the way. There's no limit. The more applications that you have and the more bins you have, the more memory consumption and more startup time. And obviously, doing byte code generation during startup is a slow operation, and it will consume compute resources, right? And the last thing, this is going to be more complicated for GraalVM to work. Because, well, GraalVM supports, as Alina said in the previous session, supports very well reflection, proxy generation. They support everything. But you can't simply go into native executable running, which was compiled ahead of time, and say, I want to generate a proxy for this interface, right, out of the box. You need to tell GraalVM in advance with metadata. Is there a different way? There is. So let's talk about it. The difference is to shift all of these operations to the either build time or compile time phase. And who knows the difference between build time or compile time? Because sometimes this is used like interchangeable. So compilation or compile time is referred specifically to the Java C invocation and nothing else. However, build time is your Maven build, right? Is the whole process. And build time, by build time, will refer to, for example, I don't know, the Maven resources plugin, right? When you filter resources with patterns and then copy to the target folder. That's build time, but it's not compile time. You see my point? Yes? So what do we have out there? What tricks can we use? There is a library called Yandex. Yandex is a Java class file indexer used by Quarkus. Who was using Quarkus here? Yeah? You two are using Quarkus? Yeah, the two? OK. So Quarkus, for example, doesn't use any compile time optimization, but they use build time optimization. So as part of your Quarkus build, they will run Yandex during the build. And during the build, they are basically iterating your class path and collecting all this metadata about your classes, your annotations, methods, etc., annotation attributes, etc. They do that during build time. And they basically traverse your bytecode during build time and produce a persistence index so that at runtime, they can load this index into memory and then query this annotation metadata without using reflection, right? It's a smart trick. Another tool used by Quarkus, but could be used standalone, is called Gizmo. Gizmo is a library to generate new bytecode, which is the way that normally Quarkus do the enhancement phase, I think it's called. Gizmo is essentially a library to produce bytecode or to mutate existing classes. Basically, Quarkus works in two ways. You can, for low-level bytecode generation, you would use the Gizmo API. But if you're writing a Quarkus extension, you can simply create what they call a recorder. So a recorder is a kind of a trick they use to let you declare the invocations, and they record them during the build, and they produce the bytecode during build time. So that those recordings are happening when you run the application. And there is yet another alternative. It's an alternative that has been there forever. It was introduced 6 months after Java 5. So that's 2006, right? And it's called the Pluggable Annotation Processing API. But the Annotation Processing API during build time has existed even before, because it who's been old enough to remember, there used to be an apt command line tool packaged by the JDK. That's not the case anymore, but that was the case back then, right? So an annotation processor is a compiler hook for Java-C. It happens during compilation automatically. If we compare this to the previous solution where it requires build time optimizations, those build times optimization will require to use their specific Maven or Gradle plugins. However, with an Annotation Processing API, it just works out of the box. So it's literally Java-C compilation running this, right? And this is the trick, this is the magic trick that Micronaut is using. We were not the first ones to use Annotation Processing API at the scale, because first of all, we have Lombok and Abstract, for example, to give. There are more examples, but those are the most popular. Anyone using Lombok here? Yeah, hold on in the room, because I have a few words about Lombok. But let me explain you how annotation processing works. It's basically done in several rounds. Because basically, during annotation processing, you're being called for a specific annotation that you're interested, right? And when your annotation processing processor is called, you could, for example, generate a source that contains another annotation that needs to be processed by another annotation processor, right? So it takes several rounds. And when Java-C detects that there are no unclaimed annotations by any processor, then the compilation is finished. You only have sources. So Micronaut will only traverse source code. We don't have any of the compiled classes, so we're not going to change them. And we don't have access to any dependencies either, right? And this is relevant because the annotation processor class path, when you write an annotation processor, is going to be different than the compilation class path. For example, during annotation processing, in that particular class path, I can have a bytecode generation library, which I'm not going to use during compilation, right? I don't need that library to compile my application, just to run my application processor. So basically, if we look at the the kind of hello world of an application annotation processor. You basically tell Javac which annotations you are interested into, and you have a process method where you're given basically there is like a kind of a Java API that will give you like the compilation unit that is being compiled with the annotations, and the run environment will tell you will give you access, like for example, to a filer object to generate files, etc. The process implementation. What can we do? For example, we can generate source code, which is, for example, what MapAbstract is doing. Anyone using MapAbstract? Yes? MapAbstract will generate sources for your mappers. And so will Micronaut in some cases. I will discuss that later. We can generate new bytecode, which is another use case of Micronaut. Micronaut will generate new bytecode most of the cases. We can also modify existing classes. Remember again who was using Lombok here, please, so that I remember your faces. I will look after you later. But not yet, not yet. But we can do something else. Like, for example, Micronaut has an annotation processor to produce an Open API specification during compilation. Right? There is also Decorate for Kubernetes. Decorate is a standalone Java library to produce Kubernetes descriptors for your applications. Right? Now let's get into the point of Project Lombok. What's wrong with it? What's wrong with Project Lombok? That's a happy pepper. So Java compilation is done in 3 stages. 3 stages. This is like Javac internals, right? We have a parsing stage. We have the annotation processing stage that I've told you about. And finally, an analyze and generate stage at the end. So in the first stage, Javac will convert the Java source files into an intermediate representation called AST, abstract syntax tree. This AST is a tree representation of your code, literally, right? Statements, blocks, conditionals, etc. Right? During this stage, Javac will check for syntax errors. Like, for example, if you have a missing semicolon, it will detect that sort of things, right? Then we invoke annotation processors. Since, as I told you, annotation processors can generate new sources, we may need to loop into this process, right? So again, analyze them, parse the sources again, create a new AST for them, and invoke new annotation processors. And finally, we have the analyze and generate phase, where basically what we do is we persist the bytecode to a class file, right? And this third stage is also when the Java compiler will do some of their optimizations, like, for example, constant folding, inlining, etc. Now, let's talk about, for example, toString in Lombok. toString in Lombok is a very simple example. And you put add toString in your Java class, and Lombok will generate a toString method, right? So to do so, it has to mutate your class, right? You agree with me? Now, I told you Lombok is an annotation processor, but annotation processing API doesn't allow you to mutate bytecode because it hasn't been generated before. It's going to happen in the third stage. So we don't have any bytecode, because that would have been the easiest way to do it, right? So let your Pollo be compiled, and then after that, with a kind of post-compile operation, then you can use a bytecode manipulation library and put the bloody toString method there. But no, that would have been too easier, right? So instead, what they do is they will mutate the AST of your class. But you will say, like, how can they do that? Because it's like they are hijacking the AST. In the second stage, not in the first stage. They are hijacking the AST and injecting methods and what else in your class. So that when they get to the second stage, they see them, right? And when they get to the third stage, they are persisted to the bytecode, right? To do so, they use like internal. There has been a lot of controversy about this. Some of them will say it's illegal APIs. It's not really illegal. It's APIs that are internal, are not meant to be used for anyone. They found it like accessible, so they're using them. It's a problem for them because they essentially have to do this for every single compiler, not only Java, like Oracle compiler, but also OpenJ9, Eclipse compiler, and whatnot, right? So I'm not even here to discuss the potential functional problems that you will have using Lombok, right? Like, for example, using that data with JPA, they will essentially persist all columns. You may not need to do that. That's a different story. I'm talking about the technical issues that you are facing without knowing with Lombok. Obviously, I don't think it's OK to use these loopholes to implement the functionality. There is Java's direction is to strongly encapsulate JDK internals, right? And the OpenJDK team will encapsulate, will literally close one by one all these loopholes they are using to implement. So they will have to catch up, right? Which means that if you want to upgrade to JDK 24 in 2 months, and you're using Lombok, maybe you will have to wait. Right? You'll have to wait. Maybe not. I'm not following Lombok close enough, but it was the case with a few other versions, right? And obviously, mutating an AST is not OK. Lombok is the only annotation processor that is not playing by the rules and will break other annotation processors. So, like, for example, if you run the Lombok processor after the Micronaut processor, it will destroy what Micronaut generated, right? So Lombok needs to be run first, basically. You can use Lombok with Micronaut, that's OK, but you need to ensure that it's run first. And obviously, this AST manipulation breaks incremental compilation. That is something that you will only enjoy if you're using Gradle. But if you have a large application, this matters, because incremental compilation will make your compilation much faster. And now a final reflection on this, and is that I can understand, with Java 6, Lombok was created with Java 6. There was like an installer, because Lombok has to be installed into the JDK originally. So I'm talking about 20 years ago. So many years ago, I can understand why Lombok is appealing and necessary to use, but I don't think it's the case anymore. So please reconsider using Lombok today. It's all I saying. And the Java language today is not like your parents' Java language. There are like modern building blocks like records and some other things. So please think about it. Now let's talk very quickly about the Micronaut approach. One slide introduction about Micronaut. Who's never heard about Micronaut before? OK. 3 things for you to remember. One is Micronaut is a modern open source Java framework. And by modern means that it's not your mother or your father Java framework. If we compare with the Spring framework was created in year 2002. In year 2002, we didn't have, I don't know, microservices, or we didn't have any of that, right? So the world has changed. Before creating Micronaut, we were creating Grails. I don't know if anyone heard about Grails framework. So we spent more than 10 years, more than 12 years, working on a web framework, which was based on Spring, Hibernate, and Groovy, and many other things. And we learned a few lessons. So we wanted to start from scratch and do something thinking about the type of applications that you create today, which are smaller, microservices, functions, etc. It's a general purpose framework. You can use it for anything you want. People typically use it to create REST APIs, but you can create a command line application, a headless, Kafka consumer or producer. By headless, I mean there's no HTTP server. You can create a serverless function, etc. And the third idea, it is highly optimized. We are obsessed with the performance. And by performance, I not only mean like production performance, like a peak throughput, which is also important. There's this benchmark called the Tech and Power benchmark that you can check to see that Micronaut is competitive. What I'm talking about here is startup time and memory consumption, because we believe that will matter. So Micronaut, as I told you, is an annotation processor that will generate during compilation all the framework infrastructure, so that at the runtime there's no reflection, no proxy generation, no dynamic class loading, and we don't scan your class path. I promise. So it's essentially a compiler, a cross-language compiler, and it's the only framework that is able to do that, not only for Java, but also for Kotlin. Groovy has compile time AST transformations. So, for example, Groovy would be Lombok could be legal to be, or like ethical to be used if they had implemented for Groovy, because Groovy supports compile time AST transformations. So, for example, Micronaut has bin introspections, which is a replacement for JDK introspector class that uses reflection. It has bin validation, which is a built-in replacement for having a validator, but generated at compile time with faster startup and smaller memory consumption. It has bin mappers, which is an alternative to map struct, built into the framework. Micronaut serialization is a drop-in replacement for Jackson. Jackson, again, is heavily based on reflection. There is Micronaut Data JDBC as an alternative to Hibernate, where the queries are computed at compile time. And we perform type checking during compilation, so you get compilation errors when your queries are incorrect instead of runtime exceptions. And much more, and all of this is fully compatible with GraalVM since day one. So we strive to help you reduce the number of dependencies, which is going to be the single advice that I dare to offer you today. Please reduce the number of dependencies, and you will be much happier. Let's look at the Micronaut implementation of this timed annotation. And in this case, I'm going to be using Micronaut AOP. So if we look at the Micronaut implementation, let me make this bigger. And we have timed in here. In this case, I have a source retention policy for the annotation. I don't need it at runtime, right? This isn't going to save much bytes, but a few bytes will be saved in the byte code. And I'm using a round, which is a hint for the Micronaut AOP machinery to work. And then the interceptor is very simple. So it has this is going to be a bin of the application context, and has the interceptor bin, which will kick during compilation. And this is essentially the around logic to wrap the interception. So the main class here, which I can run, it works again. In this case, I'm getting the service from the application context, because this service is a singleton class, right? So I'm getting from the application context. This is the same class as the previous example, literally the same class. It's in like in a core module. And then, yeah, this is the main method. And it works, right? So it's quite simple. If we run this in debug mode, we can see that this guy here is again a proxy, right? You see that? But this proxy was generated during compilation. In the previous example, if I were to look into the target folder, I wouldn't find the class file for it because it was generated at runtime with Byte body. But with Micronaut, it's somewhere in here. It's where are you? No, this is not the module. It's this module here, right? So this is the class, right? There's a new module that we are working on. I mean, it's already out there, but we are. It's like the future of Micronaut, which is called the source generation. I told you that Micronaut, by default and historically, has always produced bytecode during compilation. The reason for doing that was there was two reasons for us to do that. First of all, is that by generating bytecode during compilation, we save compilation rounds, right? What we generate is already compiled. We don't have to enter into this loop of compilation rounds. And the other reason was that, since Micronaut was able to support Java, Kotlin, and Groovy, it would have required us to generate sources in each of these three languages, and it was too much for us to do that. So bytecode will work for the three languages. That's what we did. However, users came and they said, OK, I want to see the sources of this because of, I don't know, want to debug it, whatnot. So we created a module, which is essentially a high-level API to perform source code generation. It's implemented as an annotation processor, and it works for Java and Kotlin. We are already including as part of this module few annotations that will help you reduce the need of using Lombok. Please, pretty please. But we are using internally for many other things, and there is a promise that we will never mutate your classes. So for example, in the Micronaut toString implementation, we generate a new class, right, with a toString method, and then you use it. It's a compromise between usability and what we think is right. And we think is right is to never mutate your classes or any other class for the sake of that. So obviously, doing all of this during compilation or during build time will affect startup time and memory consumption. But you may ask, why is this relevant? Because at the end of the day, I'm running a service, deploying it in a server somehow, and it's running all the time. Right? It's kept running. So startup time is happening, I don't know, once when I start the service. So why is this relevant? There's two answers for this. The first one is developer productivity, because before you get to deploy your service to this production, you will be working on it. And this is the majority of the cost is actually developing your service. So you can run end-to-end tests within milliseconds, and you can have a development mode that basically restarts your application without even noticing. The Micronaut hot reloading mechanism for development is not even hot reloading, because hot reloading will mean to basically manipulate class loaders. It's a very complicated trick. It will make a few libraries will not work. So we just simply kill and restart the process. Done. The second answer is cloud-native deployment. And there's two edges of this benefit. One is the ability to scale to zero. So if you have services that can come up instantly, then you can scale to zero when there is no load, or close to zero. And in serverless, if you have a function that takes less time, it's less money. literally. You literally save money. And if you want to squeeze the performance even more, you can use GraalVM, and it will be ridiculously fast. I'm going to skip this demo and show you this performance comparison. This performance comparison was done by Matt Rabel, who used to be a developer advocate at Okta. And he used to run this benchmark comparison of different frameworks, and Micronaut has been always the fastest in startup time and the smallest in memory consumption. And I always like to end with the use case of GraalVM, Disney Plus, which is using Micronaut and GraalVM to run a serverless function in production, because they're saving a lot of money. I don't know if we have time for questions, because there's only 20 seconds left, or actually I ran 20 seconds over the time. But please do take a picture of this QR code. Has links to my social media, so you can reach out to me, and has a simple evaluation form that I will eternally appreciate you if you can fill it, except if you're using Lombok, then I will not appreciate you. And that's essentially me, so thank you very much for being here.